SPI stands for Serial Peripheral Interface. That's a mouthful. But what does it really mean? Well, let's break it down. Imagine you have a microcontroller, which is essentially the brain of your embedded system. This microcontroller needs to communicate with various other chips to perform its tasks efficiently. Think of it as a way for your microcontroller, the brains of your embedded system, to chat with other chips. These chips could be anything from memory modules to sensors, displays, or even other microcontrollers. The SPI protocol is the language they use to communicate. These other chips could be memory, sensors, displays, you name it. Each of these components plays a crucial role in the overall functionality of the system. For instance, a memory chip might store important data, while a sensor could be monitoring environmental conditions. SPI is like a phone line for your chips. It provides a direct line of communication, allowing data to be sent and received quickly and efficiently. This is particularly important in applications where timing and speed are critical. It lets them talk to each other, sending data back and forth. The data transfer is synchronized by a clock signal, ensuring that both the sender and receiver are in perfect harmony. This synchronization is key to maintaining data integrity, but unlike a phone line, which is usually just for two people, SPI can handle multiple devices. This is achieved through a master-slave architecture, where one master device controls multiple slave devices. Each slave device has a unique address, allowing the master to communicate with each one individually. Imagine a party line, but for electronics. Multiple devices can share the same communication lines, but only one device can talk at a time. This ensures that the data being transmitted is clear and unambiguous. This ability to connect to many devices makes SPI really handy in embedded systems, which are often packed with all sorts of sensors and peripherals. Whether it's a complex industrial machine or a simple home automation system, SPI provides a reliable and efficient way to manage multiple components seamlessly. To understand how SPI works, you need to meet the key players. These key players are the fundamental signals that make the SPI communication protocol function seamlessly. Without them, the intricate dance of data transfer would be impossible. Let's dive deeper into each of these signals and see how they contribute to the overall process. There are four main signals or wires that make the magic happen: MOSI, MISO, SCILK, and SS. Each of these wires has a specific role to play in the communication process, ensuring that data is transferred accurately and efficiently between devices. MOSI, master out, slave in. This wire is responsible for carrying data from the master device to the slave device. It's like a one-way street where information flows in a single direction, ensuring that the slave device receives the necessary commands and data from the master. This is the master's way of sending data to the slave. Imagine the master as a conductor, directing the flow of information to the slave, which acts as a musician following the conductor's lead. MISO, master in, slave out. This wire works in the opposite direction, allowing the slave to send data back to the master. It's a crucial part of the communication process, enabling the master to receive feedback and data from the slave. The slave uses this line to send data back to the master, SCLK, serial clock. This wire acts as the heartbeat of the SPI communication, providing the necessary timing signals to keep everything in sync. This is the drummer in the SPI band, keeping everything in sync. Without the SCLK, the data transfer would be chaotic and uncoordinated, much like a band without a drummer. SS, slave select. Like a doorbell, this tells a specific slave device, "Hey, this message is for you." It's the master's way of addressing a particular slave device, ensuring that the right device receives the intended data. Remember, SPI is a master-slave protocol. This means that the master device has control over the communication process, while the slave devices respond to the master's commands. The master calls the shots, deciding when and how data is sent. It initiates the communication and controls the flow of information, ensuring that the data transfer is smooth and efficient. The slave devices follow the master's lead. They wait for the master's instructions and respond accordingly, ensuring that the data transfer process is completed successfully. Together, these four signals create a harmonious and efficient communication system, making SPI an essential protocol in the world of electronics. SPI is all about timing. In the world of electronics, timing is everything. It's the heartbeat of communication between devices, ensuring that data is sent and received accurately and efficiently. Think of it like a dance, where every step must be perfectly synchronized. Just like dancers rely on music to keep in time, electronic devices rely on clock signals to stay in sync. The SCLK line sets the rhythm, acting as the metronome for the entire system. Each pulse of the clock is a beat that devices follow to ensure they are in harmony. The master device generates a clock signal on the SCLK line. This clock signal is crucial as it dictates the timing for all data exchanges in the system. With each tick of the clock, data is sent out on the MOSI line if the master is talking. This ensures that the data is transmitted at precise intervals, avoiding any overlap or confusion. Conversely, data is received on the MISO line if the slave is talking. This bidirectional communication allows for a seamless exchange of information. The slave select SS line comes into play when there are multiple slaves. It acts as a gatekeeper, ensuring that only the intended slave device responds to the master. By pulling the SS line low for a particular slave, the master tells that slave to pay attention. This selective attention mechanism is vital for managing multiple devices on the same bus. The other slaves ignore the data, remaining inactive until their SS line is pulled low. This ensures that only the targeted slave engages in communication, maintaining order and efficiency in the system. SPI is everywhere in the embedded world. You'll find it connecting to memory chips. Flash memory for storing your code and data often talks SPI. Sensors, temperature sensors, accelerometers, pressure sensors, many of these use SPI to send their readings to the microcontroller. Displays, small LCD and OLED screens can use SPI to receive the data they need to show you images and text. This is just scratching the surface. The versatility of SPI makes it a popular choice for all sorts of applications. SPI isn't the only communication protocol out there, so why choose it? Simplicity. SPI is relatively easy to understand and implement, which makes it a favorite among embedded developers. Speed. It can be quite fast, especially compared to other serial protocols like I2C low pin count with just 4 wires, or even 3 in some cases. SPI is very efficient in terms of using precious microcontroller pins. Of course, SPI has its downsides too. It lacks error checking and the master has to be in charge, which can be limiting in some situations. In an embedded hardware interview, expect questions about SPI. The interviewer wants to know if you understand the basics. Be ready to explain how SPI works. Focus on the key signals and the master-slave relationship. Compare SPI to other protocols. Know the pros and cons compared to I2C or UART. Troubleshoot common SPI problems. What if your data is garbled? Think about clock synchronization, signal integrity and slave selection issues. Show the interviewer that you've worked with SPI, understand its quirks and can solve problems related to it. Mastering SPI is a rite of passage for any embedded systems engineer. It's a fundamental protocol that you'll encounter time and time again. Spend some time experimenting with SPI. Connect a sensor to a microcontroller. Read data from a memory chip. The more you work with it, the more comfortable you'll become. And who knows, your SPI knowledge might just be the key to acing that next interview and landing your dream job in the exciting world of embedded systems.